Okay, to get us started today, we're going to look at solving rational equations. So I'm just going to focus on equations for this first part. So we're going to do the front side of the notes, and then I'll make another video in regards to the inequalities. So when it says solve the following equations graphically and algebraically, let's just start with our graphs. So if I think about this part over here on the left, this 2x minus 1 over 3x plus 3, think about what you know. What is like the x-intercept? For the x-intercept, we set the top equal to 0. So we're saying 2x minus 1 equal to 0. Do a little mental thinking, solve that for x, and you get x equals positive a half. If we think about the y-intercept, remember you plug x equals 0 in, so then we get negative 1 over a positive 3 for our y-intercept. As for vertical asymptotes, set the denominator equal to 0. So if I set x plus 3 equal to 0, our vertical asymptote is x equals negative 3. And lastly, our horizontal or slant, we notice that they're both degree 1 on top and bottom, so therefore we have a horizontal asymptote, and we're going to divide the leading coefficients of 2 over 1, and we end up with 1. Now it's for graphing, and this part should seem familiar to you, right? We've been practicing this all last week, so we're going to put an x value at negative 3, vertical asymptote there, a y value of negative 1, a horizontal asymptote. We've got our x-intercept at a half, and our y value at negative a third. So, as we connect our lines, we will have in this bottom right, and then our upper left. Remember though, if you ever doubt things, especially because there's no points in that upper left, you can always do a sign chart to check. Okay, so there's the graph, and let's talk about what things look like graphically. So here we're setting it equal to 0. So if you want to think about x or y being 0, we're talking about the x-axis there. So at what point is our for what x value is y 0? It's our x-intercept. So the answer here should be x equals a half. So let's look at it algebraically now as well. If we want to think about this problem algebraically, we are going to go ahead and you got two options. You can either think about cross multiplying and put this as 0 over 1, or sometimes I just find it easiest to just say, okay, well, we're dividing by x plus 3, so the opposite of dividing is multiplying. I never want a denominator. Therefore, the top and the bottom divide to 1 and cancel out, but 0 times anything is still going to be 0 on the left, so you get 2x minus 1 equals 0, add the 1, 2x equals 1, x equals a half. Same solution whether we look at the graph or the equation. Similarly, as we look at this next one, let's think about, hey, this is really saying my function, or y, equals 4. So go up 1, 2, 3, 4. Think about that line. And then think about this point. What is that x value right there? This is a little harder to tell, right? We know it's somewhere between negative 3 and negative... Is that negative 3? 1, 2, 3. Yeah. Negative 1, 2, 3, and negative 4. Although my graph may actually not be so accurate because I know that the answer is actually negative 6.5. So because we just sketched it in randomly, I probably should have done some actual points over here. But there is actually a point at negative 5, it ends up being more, negative 6. Yeah, these ones are more they're not nice numbers, they're integers, I should say. They're not integers, they're over here on the left more. So my graph's still inaccurate to tell there. So maybe this would be a better one to do algebraically. So as we think about this problem algebraically, same thing we did above. You can either think about this as 4 over 1 and cross multiply. However, I probably would advise against that just because when we get to inequalities, you will not be able to do that. Although you could here, but it's basically thinking about multiplying both sides by that x plus 3. Be sure to do parentheses so you remember to distribute the 4 when solving. So we'd have 2x minus 1 equals 4x plus 12. Continue to think about getting the x's to one side, so I'm probably going to subtract 2x. So I get a negative 1 equals 2x plus 12. Subtract 12 from both sides, so I get negative 13 equals 2x. Divide both sides by 2, so x does equal negative 13 halves. I fine just leaving it as a fraction, but this one you probably could write as negative 6.5 if you wanted as well, because that's an equivalent form. But remember, if you have something like a third, I would not write it as a fraction. Okay, these ones down here get a little trickier. The whole idea behind it is we want to make it into the left and right side are a fraction, ideally that have a common denominator. But if that's not possible, you can always use your trick of cross multiplying. So like maybe actually let's start with b. Notice b here, like we can make it such that they have a common denominator. But here if you want to like cross multiply, you can. So 5 times 3x plus 3, you multiply 5x, 5 times 3 is 15, equals 3x plus 3. And then think about, again, like we did above, get all the x's to the same side. So I am going to subtract 3x from both sides. 2x plus 15 equals 3. Subtract 15. 2x equals negative 12. So divide both sides by 2. X equals negative 6. Notice here it says check domain to eliminate extraneous solutions. You gotta be a little careful here because not everything works. Okay, so let's just notice the domain here. The bottom, or the denominators, cannot be 0. So on the left here, x cannot be the number negative 3. And on the right here, when you set x plus 1 equals 0, x cannot be negative 1. Notice how negative 6 is not either of those numbers, so this is not an extraneous solution. However, if the answer matched one of those domain restrictions, we would call it extraneous. All right, let's do this one over here on, actually let's do C and then we'll go back to A. So we could do C the same way. I could put it over 1 and I can cross multiply if I wanted. So as I put it over 1, I get 2x plus 17, but then on this side you get x plus 1 times x plus 5. So whether you use the box or you distribute, you are going to have to multiply through there to get a quadratic. So you get 2x plus 17 equals x squared plus 1x plus 5x plus 5. If I combine that left side a little bit more, I get x squared plus 6x plus 5. And then think about moving these things over to the right side, such as equal to 0. So 2x, when you do 6x minus the 2x, we're going to get, no, not 2x, sorry. 6x minus 2x is 4x. Subtract the 17 from the 5, we'll get minus 12. So then we're saying, hey, what multiplies to negative 12 and adds to negative 6? Sorry, negative 12. What multiplies to negative 12 and adds to negative 4? We got negative 6. We got a positive 2. So x could equal 6 or negative 2. This is where you want to go back, right, and check the domain. So notice our denominator here says x plus 1. So that means our domain restriction is x cannot equal negative 1. And notice we do not have negative 1 as one of our answers, so we do not have an extraneous solution. Okay, let's go back to A now. On A, the issue here is we've got this minus 8. So before we can cross multiply, we do need to make that left side one fraction. So I'm going to rewrite the problem down here, and I'm going to leave a little space next to the negative 8. The whole idea is we want to make this x have the same denominator as the other fraction on sides, that 5x minus 25. So think about what do we have to multiply that by such that it can't have a denominator of 5x minus 25? Well, I can't just multiply it on the top. I've got to multiply it on the bottom. I have to multiply it on the top as well. So we're going to multiply the top and bottom by that fraction. So then I have x minus 8 times 5x minus 25 on the top. And I still have 5x minus 25 on the bottom equals 1 over x minus 5. Go ahead and do some simplifying there on the top. So we'd have 40x minus 40x plus 200 all over 5x minus 25 equals 1 over x minus 5. So negative 39x plus 200 all over 5x minus 25 equals 1 over x minus 5. All right, so I have 5x minus 25 when I cross multiply. And on the other side, we're going to get some quadratic. To make your life a little bit easier, though, I'm going to teach you a little trick here. Remember the top where we ended up multiplying both sides? I think that may be a little bit easier here. Because when you think about multiplying by 5x minus 25, that's really the same as 5 times x minus 5. So notice as you multiply that, that would cancel. And then the x minus 5 really cancels. So you're left with just 5 on that side, and that's going to be a lot easier of an equation to solve. So you have negative 39x plus 200 equals 1 times 5, so just 5. So negative 39x, if I move the 200 to the other side, I get negative 195. So if I take 195 and I divide it by 39, sorry, I did not know that one off the top of my head, I end up with x equals positive 5. Okay, let's go back. If we look at the original problem, whether you look at the x minus 5 as well as the 5x minus 25, our domain here is x cannot be 5. So this is actually an extraneous solution. So you can think about the answer as does not exist. Right, there's no real solution here that works. All right, check out the next video for inequalities.